All right. Hi, welcome back. All right. Information is valuable. People are prepared to pay lots of money for information. So why do people prepared to pay money for information? Well, why is it valuable? Well, it's valuable because with the information you can make better decisions in the future. So that's what we're going to look at now, is how can we compute how much some piece of information might be worth to us. Okay. Now we're going to talk about the value of information for some decision, because when you get the information matters. So sometimes information arrives too late to be useful, right? So it's not just a matter of some information having some valuable, but arriving at some particular time. So what we're going to do is we're going to look at the decision with that information as compared to the decision without that information. So how could we do that? So what we could do is we could have the utility of the network with an arc from X to D plus any no forgetting arcs, because we should remember what we're doing. So that's the value of our decisions with the information minus the utility of the network without that arc. So it's when we don't have that information. So we're comparing what we do have when we have that information versus when we don't have that information. If you think about what the information of value is, well, with this arc in, we always have the previous options are all still available to us. So all the previous things we could have chosen are still available to us, but now we have more options, and so we can always do better. Well, you never do worse. So it's always non-negative. And the only reason that it's valuable to us, it's only positive, so it's only non-negative, if the agent changes its action depending on X. And so the value of information provides a bound on how much an agent should be prepared to pay for a sensor. So let's think about how much would a better weather forecast be worth. So let's go through this example here. Okay, so now this is our umbrella decision. And if we go to solve mode and optimize decisions, optimize decisions, now let's just do it briefly, and it's 77. Okay, let's take a note of that. So the decision, so the original utility is 77. Okay. All right. So now what we're going to do is we're going to add an arc to it. So we're going to create an arc between weather and umbrella. Okay. And now we are going to optimize our decision again. So we're going to optimize decisions. And we're going to make it brief, and we get 91. Okay, so the utility with the arc from weather to umbrella is 91. The difference between those two is the value. So the weather, so a better weather forecast, a better weather forecast is worth at most, the difference between those two, what is that, 14. Okay, so it tells you how much it's worth, the difference between these two. Okay, so that's how much it could be, if you were perfect, if this forecast was really perfect, how good could it be? Well, the best it can be is to actually perfectly predict the weather. And that is 14. That's what we're modeling here. So it turns out this is an interesting decision mode. Let's optimize this. Okay, yes. We'll continue. We don't care. We're going to do this in verbose mode because it's sort of interesting. If we have this and we optimize decisions, notice there's actually nothing to sum out. And so the first thing we can do is to optimize umbrella. And we just get a decision function. So the eliminated factor is weather umbrella, and we just have to choose what to do based on whether it's sunshine or rain. Okay, so we have sunshine is leave it at home. If it's rain, we take it, because the factor that we eliminated, it was just if sunshine, we leave it at home. If it's rain, we take it. Okay, and now we're going to sum out these other variables. Notice that although forecast was a parent of umbrella, it didn't need to be considered because it wasn't in the factor when we were maximizing it. In fact, the forecast is irrelevant to our satisfaction if we knew the weather. And so notice how this algorithm we had before could work out that it's actually irrelevant to us. Okay, we still have to sum out forecast, but summing out forecast now, the only thing it's within is is this one wing, which is the value of 1, so it turns out not to make any difference. So it turns out not to make any difference at all, this value of forecast. So notice how that algorithm before automatically ignored the fact that the forecast was not relevant and automatically determined that. All right, you still have to sum out all the other variables to do that. That's going to trade a factor of 1s, and the weather is going to do that, and we're going to get a utility of 91. Okay, so let's look at this other one here. Let's look at load it from another sample problem, and let's look at this the fire alarm decision. So here is the decision we had before, and let's get rid of that message panel. Okay, and now if we optimize decisions here, and we're going to do it in brief mode, it's going to be minus 22.59. So this is the fire original. Let's do this. The original utility is minus 22.6. Okay. Now, if I have an arc, but you might want to say, well, how important is it to know whether tampering is true when we call? So what we can do here is we can go to here, and we can create an arc between tampering and call. Okay. And now what we're going to do is now we can solve this, and we can optimize the decision, and it's going to overwrite all of these because it's now a different policy. Right, so it's now a different policy than we had before. Okay, and now we're going to do this in brief, and it's minus 22.21.29. So with tampering to call, it's minus 21.30. Okay, so it's a little bit better. So it's 1.3 better. So it's a little. So this has some value to us. So now, if we look at this property, if we now look at the decision of call, right, it must actually somehow depend on whether they're doing tampering. It's actually hard to see, isn't it? So there's somewhere in here. If you look through here, so let's look at these things here. So it's true. So in this case here, if it's tampering was true and report was true, and you check for smoke and you didn't see smoke, then you're going to make a different decision depending on whether tampering was true or not. Okay, so it had to be the case that somewhere in here it was going to be different. Otherwise it would have had the same utility because you would do the same things. Okay, so now we could say, well, how much is it worthwhile? So that was tampering at calling. Well, is tampering useful when we check for smoke? So is tampering useful when we check for smoke? Oh. Let's look at, before we do that, let's look at this decision. So when check for smoke, we're never going to check. Turns out that if we can check for tampering, remember before we checked, if we check for tampering here, we never check now if we can find out whether it's tampering when we call. Okay? Now we can look at the value of information so now we can look at the value of how much is it worthwhile knowing tampering before we check for smoke. Is that useful? So is it useful to know tampering before we check for smoke? So we add this arc in. We're going to solve this, and we're going to optimize the decisions. We're going to continue, and we'll do this in brief mode, and we get minus 20.87. Minus 20.87. Minus 20.87, and that's with tampering to check smoke. It's also got the arc from tampering to call because we're assuming here that it doesn't. You have to remember. It's going to remember it. There's no point in trying to encode what we're doing. So the algorithm actually doesn't work if you start forgetting things. because sometimes it's optimal to try to encode something about, we had something before, so sometimes it's useful to encode information. All right. So now this is tampering goes check smoke. So if we think of check smoke, think of what's going to be interesting about check smoke in here. If we actually look at the decision, then because it's valuable to us, because the value went down, it's actually going to change our decision about what to do depending on whether there's tampering. Okay. So in fact, if there's tampering, we're going to check for smoke. And if there's no tampering, we're not going to check for smoke. Okay. Independently of the report. And you might think that's weird because before it actually did depend on the report, but the fact that if we have a call there, because we have this call depends on tampering, it doesn't. So interesting things happen in here. Okay, so let's go back to this, the value of a sensor. How much is the sensor worth to us? Is it worthwhile finding out information? And one of the things you have to be careful about, you have to be careful when adding an arc that would create a cycle. So how much would it be worth knowing whether the fire truck will arrive quickly when deciding whether to call them? And the answer to this is to think about how much would you be prepared to pay an oracle who could actually predict the future. So that's what we're going. So you might think about doing that. Okay, so we don't want to create cycles because we don't like cycles because we don't know how to interpret them. We can always think about how much would an oracle who could actually perfectly predict the future, how much would you pay them? Because you could actually ask them and there's no cycle involved in that. Right. The other thing we do is the value of control. So how much is the value of the network when you make a decision variable, when you make X a decision variable, if you make something into a decision variable, if I actually got to control something, is that valuable to me? Well, you could actually do this again. How much is it? What's the value of the decision variable minus it's a random variable? Okay, and we need to be explicit about what information is available when we actually start controlling this variable. So what are we going to find out when we actually control it? Okay, so let's think about here from the smoke point of view. So what we could do here. Okay, let's go back to there. Okay, so it turns out if we try to control the smoke, it doesn't actually help us, right? If we turn this into C smoke into a decision variable, and we don't condition it on smoke, then it's useless. So just making C smoke now is useful because it tells us about smoke. If we could make it a decision variable, so we chose whether we see smoke or not independently of smoke, it actually loses its value to us. Right, so sometimes controlling is bad. If, however, we control it depending on smoke, we could decide to make it a perfect sensor for smoke. We could think about what to do now if tampering. If we could say, is it useful to do tampering? So let's try and do this. So let's now go back here. And we're going to set the properties of tampering, and we're going to make it a decision variable. Okay? So it's now a decision variable. Now we get to choose whether we're going to do tampering. We're going to choose whether we check for smoke. So now we can tamper or not. So now we want to know, should we call? Is it worthwhile tampering? Is tampering worthwhile to us? Okay, so it's the value of controlling tampering. Okay, if we send lots of people in there to stop people tampering or to cause people to tamper, how much useful is it? How useful is it to prevent or cause tampering? And what's it best to do? All right, so let's go back here and let's now optimize decisions. And we'll overwrite decisions. And we can do it in brief mode, and it's minus 20.71. So minus 20.71. So with tampering as a decision, it's minus 20 point, it's a bit better than that, minus 20.7, I think. Okay, so now we have this. It's a bit better than before. Okay, so tampering is is useful. So if we look at the decision, we can say that is it better for us to tamper or is it better for us not to tamper? What should we do? Okay, so if we look at this decision, it turns out here it's better to not tamper. So it's actually worthwhile to us to not tamper. Right, so it actually turns out to be preventing tampering is useful. It's actually, if you look at the values here, it's not that more useful than just knowing whether someone was tampering. Okay, so knowing whether someone's tampering had this some value, actually causing tampering or stopping tampering. Here, stopping tampering was the best, was minus 20.7. If we look at this one here, check smoke, still is going to depend on tampering. It turns out it doesn't actually really matter about whether tampering was, if we're going to observe it, it actually doesn't matter whether we control it or observe it. We're still going to have the same value for check smoke, whether we observe it or control it. Okay? All right. So now we have to worry about it. If you control without observing, if you control a thermometer, all of a sudden it loses information. If you control check smoke without worrying about whether there's smoke, if you can set the smoke detector to be true or false depending on smoke, then it's not very useful. Okay. If you keep the parents the same, the value of control is always non-negative. It's always better to control something if we can do that. But if controlling, when we had this, with this previous example we were playing with before, with C smoke, basically said we can make it a perfect sensor. Because we can control it as perfect as smoke, it turns out we can make it a perfect sensor. Okay, so that's the value of control and the value of information. They're both valuable to us, and we can use the tools we have now in order to compute them. Okay, let's stop there. Thank you.